of 5. What is factorial of 5? 5 into factorial of 4. 4. Here factorial. I am writing the symbol as a function name. When I write the program, this will be the function name. This is the function name. But what is factorial of 4? 4 into factorial of 3. But what is 3 factorial? 3 into factorial of 2. What is 2 factorial? 2 into factorial of 1. But what is 1 factorial? 1 factorial is 1. 1 factorial is 1. This is factorial of 4. Now, 1 factorial is 1. Now, we have got the base condition. This is the base condition. Base case. Base condition. When n is equal to 1, say that this is n. When n is 1, factorial of n is 1. Factorial of 1 is 1. Now we have got the solution for the smallest problem. Smallest problem. Now we use the smallest solution to solve the bigger problem. What is the next bigger problem? Next bigger problem is 2 factorial. What is 2 factorial? 2 into factorial of 1. So what is 2 into factorial of 1? So 2 into 1. 2 into 1 is 2. 2 into 1 is 2. Now we calculate the 3 factorial. What is 3 factorial? 3 into factorial of 2. Just so we come to know that factorial of 2 value is 2. Now we apply this value 2 in factorial 2 to calculate the factorial of 3. So now factorial of 3 is equal to 3 into 2. 3 into 2. What is 3 into 2? It is 6. 3 into 2 is 6. Now factorial of 4 is nothing but 4 into factorial of 3. But just now we come to know that factorial of 3 is 6. Factorial of 3 is 6. So we use this solution to solve the next bigger problem. The next bigger problem is factorial of 4. So what is 4 into 6? 4 into 6 is 24. 4 into 6 is 24. But what is 5 factorial? 5 factorial is 5 into factorial of 4. But just now I come to know that 4 factorial is 4 into 6, 24. Now I will use this small solution to solve the next bigger solution. The next bigger solution is factorial of 5. So 5 into 24. What is 5 into 24? It is 120. So 120 is returned back to the calling function. So the bigger problem is divided into smaller parts. Until we get the solution for the small solution. Small solution, we use that small solution to solve the next bigger problem. We use that solution to solve the next bigger problem. So this is recursively repeated until we get the final solution. Here the final solution for this factorial of 5 is 120. See that 120 we have not calculated directly. 120 is dependent on factorial 5 is dependent on factorial 4. 4 is 3. 3 is dependent on 2. 2 is dependent on 1. We know only what is 1 factorial. In mathematics we have learned that 1 factorial is 1. So we use this base case value to solve the next recursive value. So 1 is used to calculate 2 factorial. This is used to calculate 3 factorial. This solution is used to calculate 4 factorial. This solution is used to calculate the 5 factorial. Then this final value is returned to the calling function. Final stdio.h. So here int factorial of int n. Now if n is equal to 0, what is 0 factorial value? 0 factorial value is 1. If n is equal to 1, so what is the return value? Return 1, because we know in mathematics that factorial of 0 is 1, factorial of 1 is 1. If n is equal to 0 or n is equal to 1. Otherwise, else, what is n factorial? N factorial is equal to n into factorial of n minus 1. N into factorial of n minus 1. Now I will write the main function. Int main, int n, printf, enter n value. Enter n value. So how we enter the n value? By using the scanf. Scanf percentage d comma address of n. Address of n. Address of n. Now I will call that function. I will call that function. So to store the result, I will take that another variable, say that f, to store the return value. So f is equal to factorial of n. Now you display the value of factorial onto the output screen, /n. F is equal to percentage d comma f. Return 0. Return 0. Return 0. So this is the program. This is the program to calculate the factorial of a number. Now when we run the program, we know that main function is executed first. Main function is executed first. Now I am entering the values for n. Enter n value. Enter n. Enter n. Say that I have entered 5. I want to calculate the factorial of 5. So I entered the value as 5. So now n value contains 5. Now I am calling this function factorial of n. Factorial of n. So now whenever open and close parenthesis is seen by the compiler, then you will treat that it is a function call. It is a function call. So now the control will come here. The control will come here to the factorial function. Factorial function. So what is n value there? N value is 5. 5 is copied into this n. This n belongs to factorial. This n belongs to main function. Now n is containing 5. Now n is containing 5. 5. Now I am checking the condition. Is n is 0 or n is 1? The condition is false. The control will come here. Now return n into factorial of n minus 1. N into factorial of n minus 1. So now return of n into, what is the value of n? N is 5. So 5 into factorial of 4. N minus 1. 5 minus 1 is 4. 5 into factorial of 4. Now what is this? This is factorial function. So whenever this is seen by the compiler, it will think that it is a function call. So the control will come here again because we are calling itself. A function called by itself is called recursion. So now here n minus 1 is 4. So 4 is copied at this place. So 4 is copied here. N, because we are passing 4 here. The new value of n is 4 now. Is 4 is 0 or 4 is 1? False. False is else false. Return n. What is the current value of n? 4. 4 into factorial of 3. 4 into factorial of 3. N minus 1 means 3. 3. So factorial is a function definition. Factorial. Here n minus 1. 4 minus 1 is 3. Now what is the current value of n? Current value of n is 3. Current value of n is 3. Now again it is checking whether n is 0 or 1. False. False means else false. N. What is the current value of n? Current value of n is 3. 3 into factorial of 2. Factorial of 2. Now again the function is called. Now what is the current value of n now? Here we are passing 3 minus 1. 3 minus 1 is 2. Is n is 0 or n is 1? False. Else false. Now return 2 into factorial of 2 minus 1. Factorial of 1. Factorial of 1. Again the function is called. Now what is the current value of n? The current value of n is 1. Now you are checking the condition. Is n is 0 or n is equal to 1? The condition is true because n value is 1. N value is 1. Now return 1 because we know that factorial of 1 is 1. Return 1. So now 1 is returned. 1 is returned. Now you use this value to calculate the higher factorial. Now 1 is used here. Factorial of 1 is 1. So now what is factorial of 2? 2 into 1. What is 2 into 1? 2. 2 into 1 is 2. Because we know that factorial of 1 is 1. 2 into 1 is 2. Now what is this 2? Factorial of 2 value is used here to calculate the factorial of 3. 3 into 2. What is 3 into 2? 3 into 2 is 6. Now, how we have got this one? Factorial of 3. 3 into factorial of 2. Now, to calculate factorial of 4, so use this value here. 4 into 6. What is 4 into 6? 24. 24. Now, next calculate factorial of 5. 5 into factorial of 4. 5 into 24. What is 5 into 24? 120. So, we have calculated all the values. 120. So, 120, the final value is written here. After completing the execution of this function, the control will come here. The calling function. Now, here, the value will be 120. Now, f is containing the value. So, f is equal to 120. 120. This is called as recursive program for calculating the factorial of a given number. Factorial of a given number. First it will store 5 into factorial of 4 in the stack memory. To calculate the factorial of 4, again you are calling the function. 4 is to calculate factorial of 3, 3 into factorial of 2, again it is stored in the stack. Now 2 into factorial of 1, again it is stored in the stack. 1 factorial we know 1. Now it will calculate in the reverse order. Now to calculate 2 factorial, use this 1 factorial value. 2 into 1. To calculate 3 factorial, use this 2 factorial value. So in this reverse way is calculated. After completing all the factorial values, the entire memory will be released. The entire memory will be released. The final return value to the main function is 120. 120.